Hi there and welcome to this video for Senior Physics Light and Waves. In this video we're going to be looking at wave superpositioning and standing waves, which is going to carry on with what we were looking at with respect to wave boundaries. Okay, so what is superpositioning? Well, superpositioning is basically the production of a resultant wave that is produced when two waves interact with each other. Now these two waves could be as a result of a reflection of a wave from a solid object meeting a wave, an incident wave coming from another source. So for example, let's think of a wave in the ocean hitting a harbour wall. The wave comes in from the ocean, but then we've got the reflected wave coming up from the harbour wall. Often what we see is that interaction, and that interaction can actually produce a large wave or it can produce a smaller wave. So what we're going to do is we're going to examine these phenomena and try and put some theory as to how they come about. So what I've got here is two waves which are meeting. Now they're two square waves. At the moment it's irrelevant really with what we're dealing with. This is just an exercise of getting you to understand what happens when the two waves meet. Now the yellow waves basically are ones which have a high amplitude, which are sitting above the white line, which is basically our midpoint. That would be what the water would be like if it was flat calm. Now the grey waves coming in from the left basically are troughs. So the troughs are two squares deep. So I've got a big water wave of amplitude 3 yellow squares up meeting a trough of a wave which is 2 squares deep. And they're moving both at the same speed at 1 square per second. Okay, so the question then is, what will happen after 1 second? So let's put the scenario in first. So after 1 second, what we'll do is we're going to start off with the troughs. The troughs are going to move across 1 square per second. Okay, so in 1 second, we've got the troughs moving across 1 square. Then what will happen is each of our yellow squares will move across 1 square per second. So they will move to the left because that's the direction that the wave speed is going. So let's start off and just show what's happening. Now remember that the yellow squares are the volume of water above the calm surface, whereas the grey is a trough. So what's going to happen is as they move across 1 square, the water's going to move into that trough. So you can see here that the bottom one's going to move down, then the next one's going to move across 1 square and drop down, and finally the top one's going to move across and then down 1. Now remember, this is a hypothetical example. It's not what happens in reality because obviously water is fluid, it can just flow through each other. But what do we see as a resultant? Well, we're not going to see anything below the water line, below the solid white line. All we'll see after 1 second is a wave of amplitude 1 square. So what's happened is our wave of amplitude 3 squares coming from our right is going to meet with the trough of 2 squares coming from our left. 2 of the squares coming from our right are going to drop into the trough to fill it up. That makes it a nice calm level, and then I get an amplitude of 1 square moving through. Okay, well I hope that makes sense. So let's see what happens, what we get when we look at a continuous wave. What is actually going to happen when we've got that continuous wave meeting? All right, well we're basically producing what's known as a standing wave. A standing wave is what happens when I get a continuous incident wave meeting a continuous reflected wave. And we have two main types of standing waves, and they work together by this process of superpositioning. Now the first type of standing wave is what we call a constructive interference. Constructive interference is constructing, it's building. These waves are going to interfere, hence we get constructive interference. Now this is a direct result of two waves which are meeting, which are in phase. Now what we mean by in phase is that a peak will meet a peak and a trough will meet a trough. So at any moment in time they will be peak meeting peak or trough meeting trough. Now with it being constructive, we get, if we can imagine looking at a peak, we get a volume of water meeting another volume of water, or we get a hole meeting another hole. So what happens is they construct or build together. They build on top of each other. So when we combine them together, what we find is we get our two waves which are meeting at exactly the same point. So the white line here is representing our calm water. Our yellow line is representing our wave coming from the left. Our green line is representing our wave coming from the right. I've just offset them slightly so that you can see the two waves. Normally they would be sitting right behind each other, but when we combine them together, we are going to get a standing wave, which you can see is double the amplitude. It's double the height. That's green added to the height of the green added to the height of the yellow. And because they're in phase, we get a largish wave which is going to be generated. And we call that constructive interference. Okay, so what happens when they're not in phase? Well, then we get what we call destructive interference. The two waves interfere with each other to actually bring the amplitude down. All right, so let's give an example. So here I've got my two waves. I've got my yellow wave coming in from the left. I've got my green wave coming in from the right. They are basically arriving what we call antiphase. So what happens here, if we look at it, we can see in our first case the yellow wave is a peak, but our green wave is a trough. Then when the green wave is a peak, the yellow wave is a trough. They're out of phase. In fact, we state that they're 180 degrees out of phase because on that sine curve they've moved across 180 degrees of that full circle. Remember the sine wave, that's 180 degrees. The negative part is another 180 degrees, which makes your 360. Okay, so what happens when they add up together? So what we get is that there's our green wave, there's our yellow wave. We see peak meets peak, trough meets trough, peak meets trough, peak meets trough, peak meets trough. Now, because they're the same amplitude in this case, they're working at the same frequency, i.e. the same speed, the result is they are going to cancel out. So basically our standing wave is going to be a flat, calm surface. So as a result, we call this destructive interference. So to recap, constructive interference is where we get waves which are meeting, which are in phase, where we get peak and peak, and trough. Their amplitudes combine together to make a large standing wave. A destructive interference is where we get peak and trough and peak, and the result is they cancel out. If they are cancelling out to the point that they are the same amplitude, the result is we will get a straight line or a flat line. However, if one peak is slightly bigger than a trough, what we'll find is a diminished amplitude that is generated, and that's destructive interference. Okay, well I hope you found that useful. What I've done in this post is put a couple of exercises for you to try with their worked answers. So download those, have a go at them, and see how you get on. Okay, thank you for joining me, and I look forward to meeting you again.